nested is a data type where you can just say there is a list of option of int and there is a nested, right? So this is a nesting, and I just want to do with my int, right? So if you see, right, this is this third part is nesting. So this is a nested list, sum to none and sum for. So I can't show you a lot of complicated code base, but this is really a very helpful thing because um, you don't want to get basically these things don't, they should not stand in your way, right? You just want these effects. The effects you need, right? Because you need futures, you need options, you need that. But you just don't need that when you want to do some manipulations. So you say that stay out of the way, let me do my stuff, right? So that's what. If you look at it, right, for comprehensions also allow us to do the same thing. So we will go there. Go back to the. Okay, here is okay. The second thing is our code, right? As any code before the Zio thing came up, right? Zio and cats effect became popular. Uh, we had even Zio has a lot of ethers, right? So you have ethers of errors and value, right? So either is a, sorry, it's a monad, right? So it's a monad. It's not a monad transformer. It's a monad, and it allows me to do a pipeline, right? So I can do like it's like shell scripting, right? I can write a pipe and pipe it one output into the another input of the another pipes and filters, right? So something like for this is a small shell script, right? So I just let's see. Yeah, so this is the for I Z. So I am this is a Z shell thing, right? I am doing a echo and then I'm just doing a paste and this. So this is a basically a command line, and either give me or any monads give me a way to sequentially compose my my effects, right? So I do something and hand it over to the next guy, and that's how it proceeds, right? So this is the we all know about that. So the next thing is basically we heavily use a lot of Scala libraries. So we use Lagom, which is a play framework, right, adapted for microservices. All APIs are future based. We are moving away from Lagom now. We are moving to Zio, but as of now the code stands as it is. We also use Lagom Cassandra library. Cassandra is a major database that we have. We also have Postgres and MySQL, and we use Scala Sleek, right? Again, Scala Sleek, you know, it's all asynchronous, it's all futures. We use Akka actors very heavily. So actors, right? Request response from outside of an actor is always a future. So that is. So these are all. So basically, the net is that we have to be async and we can't escape the future wrapping, right? So basically, in our code base, futures wrap everything, right? So you need to map, flat map. So how do you again this nesting? This basically this stands in the way, right? Future stands in the way. So first you have to peel the layer. You have to go do flat map or map inside future, reach inside the box, and then do something interesting, right? Again, it's a boilerplate. So testing, right? You also want to write a test, right? And you essentially don't want to deal with all the future nitty-gritty of like when the obviously a Scala test has great support for testing futures, future-based code, but still could be simplified, right? So that is one. Secondly, we have a lot of fan-out things, right? So futures. So I'll come to this point. I will show see that in the code. So let me go back to the code, and here is my demo one, right? So you see, right? So we see basically if you see this, I have written a mock some dummy method which if it gets an integer and if it is divisible by 2, then it's a valid result. So I divide it by 2 and return that, right, as a right side of the either. Else it's an error and I return a non-empty list. So non-empty list is again a cat's data structure, right? So it's basically you can't have you cannot have emptiness. So this list is guaranteed to have at least one or more elements, right? And it makes sense here because if you have a left, right, in this case, if you have a left, then you have to have an error. I mean, it is not possible that you have no errors and you have a left, right? So this is a something where type safety or type sanity helps you a lot, right? So it's a very declarative code. So you say that if this is the case, then n by 2, and it's a valid, right? It's a valid. Else you say invalid, and then you do a result to either. I think this is, I just pulled in valid and invalid, but you can do that as well in the either side, right? So there is this is basically it's converting that validated, right? Validated is it's a type class again in Scala that has a great interplay with either. So the great thing is validated is a applicative. We will come to that part afterwards, but yeah, this is the setting the stage. So this future, okay, so this is the thing. The same thing again, divide by 3, again the same thing. If it is divisible by 3, then valid else invalid, right? And then you have divisible by 5, same thing, right? So this is the some of the methods that we will be using just to look at the principles, right? So yeah, so demo 1 we have. Now I don't want to fill in the. So if you look at the API, right, it's returning a future of either, and I don't want to that future to stand in my way. So that's where the great part. I mean, we just love the monad transformer here, right? Monad transformers allow us to kind of the future is there, but it doesn't come in your way. So you just if you look at it. Again, I have written a monadic pipeline, and this A is just int, right? So this returns a future of either, but that future is basically just kept aside, and I just work on my A, on my B, on my C, and then I say A plus B plus C. Now this is a success case, a happy path. So n is 30. So obviously, if I run this, right? If I run this, this will be. Okay, so this is the right. So it is running sequentially, and I got 31 as a correct response, right? But this you must have seen, right? This is like I'm intentionally sleeping. The thread is sleeping for some duration, which is 5 seconds, and I'm just simulating a long API, a long maybe a API call, right, over the internet probably. So this is happening one by one, right? So this is allowing me to do basically a composition which is strictly sequential, right? So this is not a fan out. So I am not able to run my futures in parallel here, right? So this is the thing. We'll soon fix this. If you see, there is another great helper called BuyMap. So BuyMap is again allows me to, I don't have to even convert it to a future. I just say BuyMap, and then I just say E, and then print. If there's an error, then you say you print the errors, else you print the answer. So this is a very useful thing. And again, I either say BuyMap, lot of stuff, bifoldable, that is what CATS calls it. So this is the thing. Now, if you go back here to cut through the layers, so we saw this, right? This is the demo 1. Then sequencing futures. So it hurts fan out performance, right? So computations are parallelizable, so execution could overlap or not, right? So we rely a lot on this thing. Additions of list of addition, summing a list of numbers is we all know, right? That is I can divide it into chunks, and because the associative, it is inherently parallelizable. So this is good. Division is not parallelizable because it's not associated, right? I can't just take. Let us say I have a hypothetical case of some n number or a list of some n numbers. I can't just parallelize because this is not associative, right? This gives me 5 versus this gives me 20, right? So I can't just so yeah, so this is the sequencing. So let us go back to the code, and I'll show the code now. So here is a typical way, right? In Scala, we have this idiom where we start the future outside, right? So you say that ensure number is divisible by 2, and it's a future of either of non-empty list, right? So this is the part. If B is again same, C is same. Now my if you see parallel wait execution, it is 7 seconds. So all my futures overlap, right? So if you run, you see that all of them are running at the same time, and this overall execution will quickly complete, right? So the earlier one basically was strictly sequential, where this is a fan out. So this is happening in parallel. Again, the same bimap thing and all that is here, right? Now the problem is, you must have seen a lot of our people, right? Newbies, Scala newbies make a mistake is that they don't understand, or they kind of understand it, but they kind of make this mistake. So these futures have to be started outside of the for comprehension, right? So the fan out effect is achieved. The overlapping computation or execution is achieved. So, but this again, you have to remember explicitly when you are somewhat got some more experience, you can do this. But CATS as a great way again. CATS helps you here. So it is kind of you have a tuple, right? So you get a tuple of these calls, and you have something called map n, right? So map n is basically we call this as applicative functor, right? Where you have A, B, and C, and you will get the same effect. So I don't have to remember starting these futures outside and then reviewing my monadic thing. This will be the same thing. If I run my again, you see that all the 3 futures have started execution, and again within 7 seconds, right? My computation is done, right? So this is the part. Now let us say what happens when in this case, right? We all know that if any one of the future fails, then this entire monadic pipeline short circuits and breaks, right? So this is, and we get the first failure. So this is we all know, it's we all do, right? That if you get a none, then if it is basically a sum and lot of sums and there is one none, then the short circuit happens and monadic computation breaks. So do we get the same thing here, right? So let me check. So let us say I am deliberately giving n equal to 5, right? So my first divisible by 2 check will fail. So this is all still monadic. There is nothing different going on. But what I am getting is I am getting my futures all again running in parallel. But one of the first future fails, the overall thing will fail, right? So I got a non-empty list number 5 not divisible by 2. And again, I got my error back, right? So this is the same thing. This would have happened if you had pulled all the futures out and then you had done run the thing as a for compression, right? The same effect is achieved. So yeah, this is the demo. This is the demo 4. Okay, so sequencing I showed like for comprehension demo. So this is what we had performance, right? So You guys will, if you have worked heavily with futures, or will understand what this is a very common bocha for people to get into, right? This trips up a lot of times. So yeah, this is one thing where cats helps us big time. Another thing is combining maps. Again, going back to the Scala world, right? Without futures. So let us say I have two maps, right? I want to combine those maps. So I don't have to write the boilerplate. Just go and right. So I have a coordinate, right? A case class coordinate, and I just want to basically what I want to do is I have two maps, right? So one map, and there it has overlapping keys. So first map is has a key string A, and again the second has A, and there are coordinate objects, right? And again B and C. So what it does is basically it is what it allows you to do is it writes the generic thing. So what I mean by generic is that it merges these two maps, right? So this is again a CATS type class called monoid, right? So monoid basically you can say that it sums up two effects, right? So let us say it's a map, right? In this case, so a map is not an effect, a data structure, a collection, basically. Sorry for that. So map is a collection. So what it will do is it will take both the A's and it will merge the key, and then the coordinates are basically have to be combined. So how do you do that? Is that we use another CATS type class called semi-group. So semi-group is where I say that given two coordinates, I just how do I combine, right? So CATS doesn't know that, so I have to tell it. But once you have done this, everything else falls into place. So if I run this thing, you will see that map has now A is like what I'm doing is X. So I take the first X and I multiply it with, so 2 into 1 is 2, and the second is a summation. So 1 plus 2 is 3. So this is what the first coordinate, and my key is A. If there are no overlapping keys, right, then it leaves it as it is. So in that case, B remains at 2, 2, and C again gets is 15, because the first is a multiplication and second is an addition, right? So it gets that. So basically, uh, we as you go forward, right? I mean, we have this need. I mean, it feels odd at times, like you need to combine maps or you need to combine such esoteric data structures. But yes, you need to do that. And CATS has a great way, right? So this is what. So what it does is that if you give me the small, I mean, if you give me some hint, right, of how to do something, rest is all a reusable package. Right? This is an awesome thing, because you get so much for free, right? So that is the great part. Um, yeah, so I wanted to cover maybe in the next talk, whenever that happens, right? I wanted to cover trampoline, early exit from collection iterations, reader monad, state monads. So we use state monads. We don't use trampoline that much, but yeah, we use reader monads. So yeah, so these are the basically. So the great part is that CATS gives you a reuse, right, for free. So you can quickly make some collection and monad, right? Again, that is something very useful at times. But I think the great part is it has helpers for ethers, right? So you can convert things into ethers, and there is something called syntax, right? Syntax allows you to basically say that dot as sum, or like no, sorry, the dot sum. Sum is basically, you can say that I have something like well, p equal to 10 sum, and then if you look at it, so it is basically option. So you don't have to. So this is basically a very useful way because typically if you say sum of 10, right, then it will give you a sum. Right? So let us say that q equal to sum of 10, right? So you will get a sum. The type will be a sum. So yeah, okay, this is an option here, but yeah. So this at times it's working here, but at times this thing is basically hits you, right? You want basically that the parent class, and that is where this is very useful. Q equal to then none of it. Then it's like it really. Oh, sorry. Okay. So okay, so this is the this is what I wanted to cover, guys. Any questions you have?
Anyone? Does anyone have any question? Or uh, I think I have a question. Like as you mentioned that when we are talking of real world systems, like how do you decide between that whether should we use either T and or keeping a simple future either uh, E comma A? Like what are the trade-offs when I talk of readability or overall structure?
Yeah. So so this is, see, basically in our experience, whenever we have done basically see peeling the layers, right? As I said, I mean, you want to do first map into the future or flat map into the future and then do this thing. That hurts readability, right? So this is where you just want to keep out of that thing, and this I mean, this monadic way of doing things, right? So this one, right? This is typically it's a very useful thing. Secondly, where it helps us big time is that the error will log only once. So let us say your error happens here, right? Let us say either your future fails or your either fails, right? So your error percolates. So basically, what happens is it takes it forward, and at the top layer we have the logging. We have the log statement. So it logs it correctly, and the log is never ever missed. So that has given us a very big edge, because typically what happens is people forget to log, or the logs get swallowed up, right? So
Yeah.
so that problem is completely solved. It gives a very structured way for you to express your business logic. Secondly, audit logging, right? I mean, we have to do a lot of audit logging. So who did what, right? Was it a successful thing or not? So at this end of this, we insert a audit logging statement. So it ensures that all of this has happened correctly, and then after that, the audit log happens, which is again a future-based thing. So that helps us ensure that the audit log happens correctly when all the things are successfully done, right? So some user, maybe user was created, or some user logged in or something like that, right? So that ensures a very clean way, and it's a pipeline, right? So you can very easily reason about it. So anything going wrong, so if you have a high level structure, right, which is like a pipeline, it's immensely helpful. I mean, that's what I have discovered, or we are practicing it diligently for the last many years, and our troubleshooting is very effective as a result.
Right. Uh, Anyone else like have any question? I think Karan has asked you that he's saying that one second, yeah. He's saying that I see you mentioned that your product was using a lot of futures and actor pattern. Any reason to use this over IOCATS provides?
Okay. So actually, okay, we yeah, that's a great question. So IO effect, right, or this IO monad, as we say it, right? I mean, which CATS effect has and zero has. So we frankly, all these libraries, right? When we started 2017, Sleek ruled. I mean, frankly, Sleek was very popular. Lagom was very popular, and these guys, Lightbend supported that. Right, so they were commercially supporting Lagom and all that thing. And the ecosystem matters when you get into some software development, which is on which a lot of money rides, right? Then you need all the assurance of a tried and tested thing, right? So it is tried in production. So Akka was that time, even that time also it was tried in production, very heavily used and all that. So obviously, being a startup, you rely on that, right? Because that is the thing. Secondly, our learning curve, right? So CATS effect and Zio, I think, are not, in my opinion, again, guys, this is my personal opinion, are not for the beginners. I mean, you need some Scala under your belt to get productive. And thirdly, now there is a see, end of the day, the customer and management and everybody they want results fast. So see, our libraries basically decided things for us. For example, you guys must know, right, that Zio and Cats Effect don't like futures, right? So because futures are not referentially transparent, right? They are not RT. So that is the major reason, and all the libraries which we're using, they're future based. So yes, we could use the bridge APIs and just get out of that logjam. But learning curve was frankly a big thing. I mean, for us, we are a strictly an immutable company, right? We you will not find even a single mutable statement in our code base, and that alone, I mean, I had a very Herculean task of basically convincing how to get that right. So in Akka, right, we have that become pattern, right? You have to so if you use immutable data structures, you should use there is a become pattern and there is a those things are in state changes in place and all that, right? So all of that people had a hard time, frankly, wrap their minds around that. Rock the JVM and these things were not there that time. Rock the JVM started a bit late, and we were essentially on our own. So this was a pragmatic decision to go for tried and tested simpler libraries. Yes, now if as I mentioned, right, we are moving into Zio. So if I were going to develop the product, same product today, I would without hesitation go for Zio. But yes, the learning system, the ecosystem, right, everything was not very mature that time. That's the, so.
Hmm. So,
We use a lot of Akka Stream also. Now, yes, again, Zio Stream is there, which is a great piece of software, but that time it was not there. So, yeah.
hmm. So I think like you gave emphasis like back in 2017 and now Zio and Cats are a lot more mature, and you
Yeah.
already answered
Yes.
that if you are writing a new piece of code, you would prefer to pick Zio. So like, do you see any do you see any like trade-offs between using any Cats or Zio or using inbuilt future or what you have currently? Like, are there any trade-offs you notice or something or another?
Trade-offs in the sense that see now there is no doubt, right? Zio is there. I mean, for sure, this is the way to go. Uh, the way they reason about the referential transparency, I completely agree with that because you see, right, if you use Sleek or if you use Akka Streams or any such framework, right, that blueprinting, right? So you blueprint things and then you end up the world. That's what they call it. You run it, right? So you have a dot run or you have something like that. That's a very enduring theme, and I think that's a great theme because you can do a lot of reuse, right? Even in Zio, I mean, if you can basically cobble together things very effectively. So the appeal is, I would say. Zio is obviously great. I mean, it's a lot of stuff. But so, for example, you don't have a simple way, right, in the Scala thing, the one that we use, to retry APIs. So let us say you want to. So we use obviously service mesh to do that. We use STO, Kubernetes, and we have the facility. But at a Scala language level, it was not very. I mean, was not there. So we have these interruptions, right? Interruptions again is a great part that Zio and Cats effect gives. Which again, I mean, once you start a future, you start it, right? You have no way to basically cancel it or anything like that. So those things are really awesome. And the fiber stuff, right, that they have. I mean, see, a big thing, big tuning we had to do was around execution contexts, right? So you have very definite patterns like for working with database libraries, right? You have to have a fixed thread pool. So but other places you use fork join, right? So those things are, but I mean, you need to know a lot of that to get it working correctly. My point is, we keep discovering. For example, Aka actor logging, right, can't be mixed with future logging. Now, this is something very subtle and it can trip you up. I mean, this is without knowing you have got a race condition on your hand, right? So those things are really, I think a lot of that has gone. I mean, and Zio or Cat's effect, right? The way they compose things and the blueprinting and not having that eager evaluation of futures is great stuff,
Yeah.
I think.
Mm.
So that's the thing.
And also, okay, so Rishikesh Kumar is asking thoughts on the try type versus either type for a bigger code base.
Yeah. So see, basically, try is something you have when the see you interface with Java APIs, right? At the end of the day, so much big ecosystem of Java libraries. So Java has that exceptions, right? Scala people don't use throw and all that, right? Because that is not a pure thing, right? Exceptions are not pure. So, but when you interface with Java, yes, you need to use try and do that. But basically, see, ethers are like awesome because they are again a pure thing, right? You want to uh, go back and say that this is my by type, right? I mean, I have a error or I have a value. And that is an awesome thing where try is something not very much preferred. I mean, unless you are interfacing with something which is really throwing an exception. So we do that. We use try, but then we immediately convert that. The cats give you a helper, right, to either, and then it gets converted. And then either is this very, I mean, very useful data type. I mean, Zio also. If you look at Zio, it's either blown up either, right? I mean, that's how it is. So yeah,
Hmm.
you should use either. I mean, try is not something that.
Uh, And also like you mentioned that I think you always, your whole code base is immutable, and you always advocate that in the whole on all product that you're building. Like sometimes what happens, what I have heard from others is that what's happening is that a lot of time management and other people like who are not technically aware of stuff don't really care about these all things. Like even if it does take a bit more time to develop immutable code, like they want stuff to get done like faster due to product requirement and other stuff. Like they don't really care about immutability, they just care for stuff to get built fast. So like how do you convince them, or how do you go about it?
Yeah. So see, basically, if you look at our code base, right, there is a huge. I mean, we call it massively parallel, right? There is a piece which is it is basically a finite state machine which is massively parallel, right? So Like for example, at per second, there are 1,000 transactions could hit us, and each transaction goes through one instance of the FSM, right? So that is the scale. Now, ensuring that we don't have any Heisenbergs, right? We don't have any races or and all that. That is where initially you would go fast. So how you convince your management? I mean, again, see, the thing is, you have to stand your ground. I mean, that there is no two things about that. And you, I understand. I have gone through that because what is the value? How refactoring is going to help us, right? Paying technical debt, how does it help, and all that. They all will have that kind of thing. But you have to ensure that initially you may go a little slow, but as now later our product, right, it is in it's deployed in around 20 banks right now, and more are coming in, right? And there the thing is that years and years it is running. I mean, the thing is, it is there is no in all these 6 7 years I have seen only two Heisenbergs, and they were a wrong mixing of futures and afters, and that was quickly fixable, right? Versus if I just wind the clock the other way, right? C++ threading, it's a nightmare. I mean, if you have mutexes, and if you forget to unlock a mutex and all that, right? Even there you can do things correctly, but it's a nightmare. So basically, see, the thing is, immutability came for a reason, and that reason is obviously thread safety, right? I mean, a major thing is thread safety. So a lot of those problems just go away. So I think you have to stand your ground, my friend, and obviously customers are unforgiving. I mean, I'll tell you, they don't they don't care about anything like what you've done and all that, right? They just want that thing to stabilize overnight. And I can't. I mean, I can't even think of doing that without Akka. I mean, at this point, right? Obviously, fibers and geo and all that stuff is there, but uh, doing it with plain threads and mutable things, it is simply a no-no. I mean, that would this product won't work, frankly. So if you look at other languages also, right? Go, for example, as Go channels and stuff like that. So the general industry trend is that don't use threads by itself, right? Go for higher abstractions. Yes, that is one convincing argument
Mm.
forward.
Yeah. Yeah. Uh, does anyone have any other question?
Yeah, I have another question. So coming from Haskell, everything is lazy evaluation, things like that. So how often do you leverage something like, I mean, I know Scala does support it, but how often do you leverage something like that in your code bases?
So see again, yes, I mean we frankly see the thing is laziness has its place. I mean, for example, our thing, right? We generate a lot of code as a domain specific language, right? And I remember that one instance where we wanted to generate variables. So for some, we have internal parsers, and thus that parser for that basically code, right? We generate a Scala code. So that variables we wanted a way, right, where you keep generating. So for example, it's like P1, P2, P3, P4, P5, like that. You keep generating the variables, and that's where streams have helped us tons actually. I mean, I can't imagine doing that with something else. Right? So because you don't know, I mean, it essentially happens at runtime. So you have no upper bound. You don't know, right? One case, maybe one scenario parsing, you may need P1 to P10, and another you may need P1, P2 to P35. So this stream, right, as a data structure, is again lazy and it's awesome. So that is what we use. That we use actually a part of it here in our Akka streams also. So there are places where laziness definitely helps. Um, yeah, but yes, I mean it's again you need to get the things out quickly. So declarative, immutable, and just enough laziness, and you get it working. So yeah, it's a big help. But I mean that is something you need to kind of have a proper use case for.
Got it. Thanks.
And Keshav is asking, did it affect when Akka licensing changed?
Yeah, that's again a great question. Actually, see, Akka is frankly the licensing as of now, right? It applies after your turnover reaches a certain big amount, right? So we are still some miles to go before we reach there. But essentially, we have PECO, right? So PECO is again pretty mature. And if you guys are following that, right, the Play framework is now also supports PECO. So we can, and it's all basically plug in and just you use that, right? Same API, same everything. So PECO, I think, will mature and we should be okay. I mean, we don't use much of like cluster sharding. See, there is a we had a hard time, right? I mean, we had a very hard time. Earlier, we were not containerized, we were not Kubernetes. So we just went on a JVM, and that gave us so much of pain, right? So then we moved in the direction big DevOps and all that. And when you go Kubernetes, what we have found is that the Akka clustering, sharding, and all that stuff and Kubernetes don't mix that well, right? So Akka is a clustering solution, right? End of the day, it has its own cluster singletons and it has its own entity sharding and stuff like that. And this space, right, is where Lightbend controls. I mean, you have to be their subscriber. For example, they have a great this one, right? They have a plugin, SBT plugin for doing telemetry of your Akka code and all that. But again, that cinnamon is not free, right? And that as a startup, we couldn't afford that $83,000 per year, right? That is simply out of our budget. So things like so the thing is PECO is always there, but you have to be see technology and appeal of technology and love of technology is one thing, but you have to be always careful of the learning curve